So let's continue on and let's start with some recovery strategies. So what we want to talk about are backup storage strategies, our recovery site strategies, maybe some multi-processing sites, and some system resilience, high availability, and some fault tolerance in there. So our backup storage strategies of what can we do with our backups? I mean, we have different things, if you want to look at it that way, that we can do. We can have, say, off-site storage. That seems pretty self-explanatory, right? We are storing our backups off-site. But why do we do that? Right, for security purposes, and it makes us a little bit more resilient because you can take your backups of your data, and where you store that backup is pretty critical. Now, if you only have one building, right, your organization, you have one building, you could take the backup of the data and store it somewhere else, but it's still in the building, right? What if something was to happen to the building, catastrophically happen to the building? Well, not only did you lose the original data, the server, but now you've also lost the backup data. So it didn't really do us much good because now we've lost everything. So what about off-site storage? Maybe you could, if you use tape backups, maybe you could take that tape to another building down the road, put it in a vault, put it in a lockbox, put it in a safety deposit box if necessary. That might be a little far-fetched, but my point is it's off-site. So you could physically take it off-site and lock it away. Again, we want to make sure that it's secure. We have to have that access control for it. We don't want to maybe just take it to your home and leave it on the shelf. That might not be the best idea. It might be against company policy at that matter because you're removing data from the facility to an unsecured location, and that may be against policy. Let's say you have multiple buildings. Moving it from one building to the next could be considered off-site. You're taking it out of the building, but you're not really taking it off, say, your campus area. So depends on, I guess we could play with words a little bit there. You're taking it out of the building, but you're not taking it off-site as far as away from the infrastructure. And sometimes that's not possible. Sometimes you can't take it off-site. So if you can't, let's say, again, you do physical backups with a tape or to something like that, maybe electric vaulting would be the way to go. Moving that data electronically over a network. You're still sending it off-site or in the cloud somewhere. So that data, the backup data, is not kept with the server. It's not kept with the original data. It's not kept in the building or on site, which is good, right? That's what we wanted. But now we have other safety concerns, right? Other security concerns as far as having all of our proprietary data backed up and moved across the web, out the internet. Is it encrypted now? Who's taking care of that backup on the other end? It may be another one of our facilities. Maybe we move it off to a remote location. Then we have to think about encryption or tunneling over to the remote location. Physical security at the remote location. Encryption, data at rest, data in transit. Think about, are we protecting it in both states? So electric vaulting is moving that data, moving that traffic, if you will. It's moving the data, creating traffic to an off-site. All right, it's not really mirroring. We're not mirroring our database or our information where it's live, real time, but it's not like tape backups where we traditionally take the tape and we run a tape backup and we wait for it and then we can take it off site or put it in a lock box or put it in a lock cabinet or fireproof vault or wherever. It's kind of in between, except it is electronic, that's the electronic vaulting part, but we're moving it off. Now we could have tape rotation, and you need tape rotation. You need some procedures, you need a policy in place of what it is you're going to do and how you're going to rotate your tapes. And when I'm talking about tapes, I'm talking about your tape backups or the tapes that you're going to use for your backups, right? You may have a server that has a drawer of tapes. It could be automated, but you put, 10 in there, let's say. And that allows you to keep 2 weeks worth, or about a week, and let's say we put 14 in there for math's sake. That gives us 2 weeks worth of data that we can back up, or 2 weeks worth of space. Because you could use a tape for each day, right? Now, I'm not talking about strategies as far as full differential or incremental yet. I'm just talking about the tapes themselves are rotating, because we can rotate through the back of the tapes, and then once we get to 14, we can tell it to rotate back up. And then we're going to have the last 2 weeks of data somewhere in case we need to go back. You may need more. You may need to put a month's worth, right? Maybe your policy says we have to keep a month's worth of backup data at all times. So we're going to rotate through 32 tapes or 35 tapes or whatever it is to make sure we have enough. You know, some organizations where I used to work, we had a week's worth of data. So we could back up, restore, I should say. We could go back 7 days or 6 days, because tape 7 became tape 1 again, I think. So we could go back that far if we needed to. It's going to depend on your procedures, on your policies, on how much you want to retain, how much of that data. But you will have a rotation policy on your tapes. You may not have a rotation policy at all, which I can't quite see, but you may just use a new tape every day. Now it's going to get quite expensive, and your storage for all the used tapes is going to become quite cumbersome pretty soon. So you're going to probably need like a dedicated room, or at least a dedicated area in your server room for that information. I probably wouldn't advise that. And then I mentioned full differential and incrementals. Those are the backup types we can have, right? We've done backups for years. As far as I can remember being in IT, we've talked about doing backups. You know, we were pretty diligent about doing it in our organizations and our enterprises. I found that home users and small offices, they're not quite as diligent when it comes to backup strategies, mainly because they don't have the resources, they may not have the tech skills and the know-how to actually do it properly. You know, they may say, well, I'll back up that folder. And that's good. Maybe they did, but when they say they're backing up that folder, they're making a copy of it and leaving it on the same hard drive, on the same computer, in the same building. So we have a copy of it, and I guess it's kind of backed up, but it's a very insecure backup, right? Because I always ask them, listen, what if I stole your laptop? And they just kind of get that look on their face like, well, I just lost everything, right? And the backup. So that goes back to the off-site electronic vaulting. But what if we wanted to back up everything on that hard drive? We have to start with a full backup, right? So if we're going to start a backup strategy, we want to put something in place, our backup processes. We want to start with a full backup. We want to back up everything on that drive the very first time. And then, depending on our strategy or whatever it is, however it is we want to do our backups, we could do a full backup every night, which takes the longest because you're backing up all the data. Or we could start with a full backup and say do a differential. That just takes the changes from the last full backup. Or we could do an incremental, which takes the changes from the last incremental backup. So for example, we could do a full backup on Sunday. We could do an incremental on Monday, so it gets the changes just from Monday. We could do an incremental on Tuesday, which takes just the changes on Tuesday. We could do a differential on Wednesday, which would back up Wednesday, Tuesday, and Monday, because it goes all the way back to the last full backup. So now we've got double copies of Monday and Tuesday just in case. So on your tape rotation now, you could take Monday's and Tuesday's tape, because you have a backup of Monday and Tuesday now. You could take those tapes and use those for Thursday and Friday. Because we don't need that. I mean, you don't need, unless your policy states you need multiple copies of something backed up. So now we can rotate those tapes back to the back. And Monday's tape can become Thursday's tape. And Tuesday's tape can become Friday's. So we can do incremental again. And then a differential on Saturday. And then we can rotate the Thursday, Friday tapes back to the next week, back to Monday and Tuesday. And then we can take the differential from Wednesday and make it the next Wednesday. because we're going to do another full backup on Sunday. So you can see we could keep a week's worth of data by rotating in and out about 4 tapes. It just depends on your backup strategy. If you're going to use your full backups, differential backups, or incremental, and that's totally up to you. It's up to you on the data that you're using. I worked with a company, consulted with them. They did a full backup of their data about every 2 hours because it was that critical to them to have a backup at all times. So they were doing backups all the time, full backups. You may not have that need in your organization. You may be able to do it incrementally throughout the day or once a day or however you need to perform your backups. Now we also have some recovery site strategies. When we talk about recovery sites, and you've probably heard about these like a hot site, a warm site, and a cold site. Now a hot site, that's the location where an organization can relocate at pretty much a moment's notice. Something has happened. We have had an incident, right? A catastrophic incident. Well, we need to get production back up as fast as possible. Well, if we have a hot site, we already have all the necessary hardware. We have the necessary software. All our critical applications are already there. All the data is mirrored in real time. So technically, we're not down. The site may be down, but the business processes are always running, right? So the hot site will have the capability to allow the organization to resume critical operations within a very short amount of time, if not instantaneous. It kind of depends on how fast we can get personnel there, if there's already personnel there, if there was any latency in getting the data moved over or having it mirrored when something catastrophic happened, right? But a hot site, we're ready to go. Now, out of the 3, it is the most expensive because we're pretty much doubling our infrastructure. You may be paying extra people to man this, but for some organizations, that's the benefits outweigh the risks or the cost. So a warm site, kind of moving down now, has some aspects of the hot site. It's not real-time data, all right? It has hardware, the software, and connectivity, but it's going to have to rely on the backups. So that's why off-site backups or that electronic vaulting is going to be so important to do a proper backup and get it away from facilities that have the original data. Because if we have a warm site, and that might be the remote facility that we're moving that back up to, but now we have to take that data and restore it to bring this site back up. So we might be back up in a day or 2, maybe faster. Depends on how warm you make it, I guess, right? And then the cold site, being the least expensive because, well, there's not very much there, right? It does not include backup copies of data. It doesn't contain any immediately available hardware. We may have a building, we may have electricity ran to it, may have utilities ran to it. They may not be turned on. They're just there and ready to use. We need to get that turned on. We need to get equipment in there. We need to get the data in there so we can start bringing production back up. Now, this is going to take the longest amount of time to bring back up for our recovery, mainly because it's like a big empty building. So we have to go through the process of getting everything started up. So, I mean, we're looking at a week, maybe 2 weeks. It depends, again, on if you have the utilities turned on at all. If you have them turned on, how fast can we get personnel there to set up systems, install applications, get the data on there and get us back into production. We can also have multiple processing sites. Now, these are multiple sites that we just spread out, right? We've spread them out across the globe, the nation, or in a particular region. It depends on your organization, again, on where you want to spread these things out. Now, these can be an advantage, all right? And well, they really are, if numerous locations are required to conduct business. So think about, large corporations like Amazon, Google, Microsoft, Apple, right? They have multiple processing sites, right? They just don't have one building that they're running all of these processes from, all your shopping, all the requests that they have. They're global. So all of these sites are spread around strategically where they need them to conduct business. And again, that not only helps them to service their customers faster because you can get to a particular region quicker. What happens if a particular region goes down? Well, that doesn't mean that they're out of business. Another region or another data center in another region, another area will pick up the slack. Now, you might lose some of that speed, right? Some of that efficiency, but you're still in business. You're still in production. If you kind of think of it, I mean, it's like sticking a business internet on top of the theory of the internet in the first place, right? It's not one node goes down, will the whole internet come down. So not one region of our processing sites go down, are we dead in the water. We can still maintain our business and still maintain our product line. Now, when it comes to system resilience, high availability, quality of service, and fault tolerance, we need to plan ahead. All right, a plan, you have to have a plan. And anything we do, we have to have a plan. You're going to have to plan ahead for fault tolerance. So redundant hardware, that's important for fault tolerance. So what type of redundant hardware could we have? Well, we can have multiple CPUs. We could have multiple power supplies. We could have multiple network interface cards. We could have multiple hard drives, which is very popular. Let's get away from the system. We could have multiple routers, multiple switches, fault-tolerant firewalls, load balancers, servers themselves. Maybe we just don't have redundant power supplies, but we've got two physical servers that are identical, and they're mirroring each other, for example. Fault tolerance. We could have clustering set up. What else could we have for fault tolerance? Redundant connections out to the internet, right? Redundant ISPs, where you could bond those together. It's very popular to do, right? You've got two internet connections come in, you bond them into one. So you get a 50 meg connection here, a 50 meg connection here, and now you have a 100 meg connection. But if one of those go down, right? Let's say this ISP gets attacked, DOS attack. Well, that link goes down, but we're not dead in the water because we have another ISP over here that we're paying for as well. So we're going to lose some of our throughput. We're cut in half, but we're not going to go all the way down. So that's that fault tolerance we can build in there. Now, when it comes to the hard drives and fault tolerance, there are something that you need to be familiar with. They're called RAIDs, R-A-I-D, Redundant Array of Independent Disk. And we have levels 0 through 5. Now, RAID 0, this is a striped set. Right? That's what you need to associate right there. It relies on striping data across multiple disks. So in a RAID 0, right, you may have 2 or 3 disks. All right, let's say we have 3 physical disks. All right, there's no parity, meaning there's not really any fault tolerance. This is more for speed, okay, quality of service. So what you can do is set up a RAID 0, and it will write a little bit to this disk, and it will write a little bit to that one, and write a little bit to this one, and then it will go back and start the process over, right? It's striping it, writes it in stripes as you are reading and writing to this particular disk, right? So not a viable solution for disaster recovery. This would be more for our quality of service because the performance is going to be improved. Now, we have something called a RAID 1. Now, in a RAID 1 configuration, you have 2 hard drives, all right? And they need to be the same size, or let's say this one's 500 gigs, the other one has to be at least 500 gigs. So the one that we're going to mirror, we have to at least meet that size. Now, if, let's say, this is 500 gigs and this is 750 gigs, we're going to lose the 250. You can't use it for something else. So don't think, well, I'll just mirror that part and then we'll use it. Can't do that. It is a dedicated drive, and that's all it's for. So what can we do is install everything on this drive, right? Put a blank hard drive in there, same size at least, and you mirror all the data. So whatever's written to disk 0 gets written to disk number 1. Now, this is not very good for performance because we're writing in 2 different places, right? You're writing it twice. Now, if you're using something like solid-state hard drives, you're not really going to take a big performance hit because they are extremely fast. But in all intents and purposes, it is a little slower because you're doing double the work. Now, the good thing about a RAID 1 is that now we have some of that fault tolerance because everything that gets written to 0 also gets written to disk number 1. Well, of disk 0, the original disk, if something happens, right, it crashes, it dies, whatever, because hard drives only last for so long, we can shut the system down, remove that disk, take disk 1 out of that spot and put it where disk 0 was, turn it back on, and we're right back in business. It's like it never left. Now, that's if something physical happens to the hardware. If you get a virus or a worm or something that has corrupted the data, that corruption may have very well gotten copied over as well to the other disk. So that may be that would be an issue, right? So I'm talking hardware failures here. So again, we could take that out, put it in place, turn the computer back on, and the computer won't know the difference. It'll come right back up. Now, you don't have your RAID anymore, so it may throw a fit about that. It's going to say something about misconfiguration, so you'd have to break that RAID 1 because you no longer have that mirroring going on. And then some other ones that we have. They're not as popular, but they're still available to use, and that's a RAID 2, 3, and 4. Now, a RAID 2 is striping, but it's performed at the bit level. Now, this is pretty costly. It is more difficult to implement. That's probably why it's not as popular because we don't really use this. Firsthand, I've never used a 2, 3, or 4. 0 and 1 and a 5 all day long, but not these guys. A RAID 3 configuration, we're still doing the striping, right? And this is at the byte level. This uses a dedicated parity disk. So what does that tell you? Gives you some of that fault tolerance. RAID 4, this is striping at the block level. This uses dedicated parity. Again, some fault tolerance. It just depends on how large of a chunk you need to write. Bit, byte, or a block. And then RAID 5, probably the first one that I guess I learned when I started in IT working on server systems. This is striping with parity information that is distributed across multiple disks. All right, so the parity information is kept not on a dedicated disk like 3 and 4, but it's spread around. So if any of the drives go bad, now we can just pop that drive out, pop another one in, and the RAID will rebuild itself for us. So they used to have, growing up, I guess in IT, we always had a hot swap in the server, right? It was part of the server system. The server knew it was there, but they called it a hot swap because you could, without turning the server off, take the bad drive out, take the hot swap out and put it in its place and let the system do its thing, right? It would rebuild it. So in the event of a single disk failure, that data can be recreated from the information from the parity and the data that's stored on the other disks because it knew what was supposed to be on there. Now, if we have 2 of them go out, you're in kind of a world of hurt when it comes to RAID 5 because you're not going to get that data back. So if 1 goes out, we'd be okay. So that's it, a RAID 0, RAID 1, 2, 3, 4, and 5. We need to be familiar with those. And now what about disaster recovery processes? We need to talk about response, our personnel, communications, assessment, restoration, and training and awareness. Now, response for our disaster recovery plan or our disaster recovery process, a DRP is how you're going to hear it. in order to begin the disaster recovery process, we have to have an initial response. That is the process of assessing the damage to see what's going on or what has happened. Now, speed and quality always, but speed is important here. All right, it is essential during this because we need to get there as soon as possible so things don't change. Now, the initial assessment is going to determine if the event in question is really a disaster. So what may be a disaster to some may not be really a disaster. Remember, we talked about incident handling and how an incident may really just be an event. It depends on how you look at it, and that's your job as the security professional to decide, yeah, this is a disaster. We've got some real problems here. We need to, execute our plan. So if a disaster is declared, and we know this is pretty bad, now the recovery team needs to be activated. All right, so you're going to have a disaster recovery team, just like we could have an incident response team. It may be the exact same team. Usually this one's a little bit different, but we have to activate them, call them, get a hold of them, email. They may be on site, right? They need to be jumping into action here. So depending on what type of disaster, the building is catching on fire or is on fire, that one shouldn't be hard to realize that's a disaster. If we're under some type of natural threat, storms, tornadic activity, hurricanes, something like that, that's going to be a disaster. But what could happen is communication could start to become a problem, especially if the disaster, say, took out your phone lines or any type of the cell towers, right? Do we have two-way radios that we can use? Are those available in our organization? Do we have those in our disaster recovery plan? Do we have those in a secure area so if something happens, they're on charge, they're ready to go, they've been tested? Can we, everybody grab one and go and do whatever it is they need to do for their part of the disaster recovery plan? We could also use something like calling trees. So instead of you sitting there and calling a dozen people, right, you call 2, and then those 2 call 2, and then those 4 will call more, and then everybody calls their 2 people, right? You've seen a calling tree where it starts with 1 and they call 2 people, and those 2 people, they call 2 people, so now we've got 8, and then those 8 can call, and it moves on down and it spreads out like an upside down tree. And eventually you'll reach everybody. Depending on how many people you have on your team is going to depend on how long it takes, but it's usually fairly quick. So communications is one of the most difficult aspects of disaster recovery. We have to make sure that we are consistently giving status updates. Let people know what's going on. We want to get those updates back to the central team that is actually managing the response and the recovery actions or the recovery process of this disaster. Now, the typical communication method of leveraging, say, an office phone like we talked about, will probably not be that viable option. That's where hopefully maybe we got something like two-way radios where we can stay in radio communication. And as long as we're in depending on the radio you buy, you may stay within a couple miles of one another and you'll be just fine. Now, in addition to communication of internal status regarding the recovery activities, the organization must also be prepared to provide external communications. So we might be disseminating details regarding our recovery status, say, to our stakeholders or to the public, to keep people informed, again, to let them know what's going on. They may have loved ones there, and people want to know what's going on, right? Are they safe? What's the status of your recovery process? What's the damage? People want to stay informed. Then we're going to do an assessment, or we need to be aware of an assessment. So we did an initial assessment, was carried out, right? We showed up, we said, yep, this is bad, this constitutes a disaster, let's go, let's move into place, right? Now this is a more detailed and thorough assessment. This is going to be performed by the whole team this time, instead of the first person on site saying, yeah, this looks pretty bad. Now we're bringing in the whole team. The team is going to start doing their assessment, and they may be responsible for particular areas or particular technologies or particular processes. And one or two may go check it out and find out what's been affected, and then come back and report to the team. Again, that leads back to that communication, so we can get that information, disseminate that information back. I guess that would be aggregating the information back to the team leads or the project manager or the disaster recovery manager. So the team will proceed to assessing the extent of the damage to determine any steps or the proper steps to ensure the organization's ability to meet its mission, to get back into production, to start meeting its customers' needs. And then we're going to move to restoration. So the primary goal of the reconstitution phase or restoration phase is to successfully recover critical business operations at either a primary site or a backup site. Remember we talked about hot, cold, warm sites? If we decide this is not going to work, we cannot recover from this at our primary site, we need to make the decision, somebody needs to make the decision to move business processes off to one of our alternate sites or a secondary site. So if an alternate site is going to be leveraged, if it's something that we decided, yes, this is what we need to do, we need to have adequate safety and security controls in place to maintain the expected degree of security that we normally have. So just because it's a disaster, right, and something has happened that we need to move off to our secondary site, this building is deemed no longer safe, so we have to move. Make sure that all of our security policies and processes and procedures move with us. When you're part of a disaster, your adrenaline's going. You're thinking about 1,000 things a second, but we still have to maintain that security posture, because if we're moving business processes, right, we're moving our data, we're moving our assets. Well, we're already dealing with one disaster, right? Maybe whatever, building collapse. We don't want to create another disaster by lessening or forgetting about our security. That would be a big opportunity for somebody, big target, and it could be a big vulnerability if we're moving millions of dollars of data and we don't protect it properly. So make sure that our security follows us, all right? This is going to be in our plan. This is not like it's going to be an afterthought, or you'd be like, oh, we got to do security, right? It's going to be in your plan, but make sure you're doing your due diligence to keep everybody on that track. And you're probably not going to be the most popular person when you start throwing around security policies and procedures, because people are just trying to get into a building and get set up and get business back up into production. But stand your ground. You're doing what you're supposed to be doing. You're protecting them again from probably a worse disaster. As long as there was no loss of life in this initial disaster, you're preventing that company from going totally out of business, because buildings can be replaced. Human life cannot be replaced, and data, once it's stolen, you can't get it back. You can't make it safe again. Let me put it that way. Once it's gone, once it's out there in the public, it's out there in the public. So if it's data that's not supposed to be in the public, that's a problem. So that's why I say it could be a worse disaster if you don't do your due diligence and maintain that security posture. But we don't want to expose ourselves to further security risks or further security incidences.